Hi everybody, it's Miss Austin and we're going to be doing the Unit 3 Lesson 3 practice problems. And we've been talking about exponents as fractions and what those mean. So here we go. Number 1 says complete the table, use powers of 64 in the top row and radicals or rational numbers in the bottom row. So the first one's filled in for us. 64 to the first power is 64. 64 to the 1/2 power. Today we learned through explaining through the use of our exponent properties that the 1/2 power actually means square root. So what is the square root of 64? 8. Okay, now how could we get 4? 64 to the what power would give us 4? And it looks like, oh, I thought maybe they were going in order. How does 4 relate to 64? 4 is the cube root of 64. So that'd be 64 to the 1/3 power. 64 to the 0, anything to the 0 power is 1. How does 1/8 relate to 64? Well, I know 8 is the square root, but now it's the reciprocal, so that must have meant that this was a negative, right? The negative is what gets me the reciprocal of this. So that'd be 64 to the negative 1/2. And then 64 to the negative 1 power, right? That means I have 1 over 64 to the positive first power. Okay, suppose a friend misses class and never learned what 25 to the 1/2 power means. Use exponent rules. Your friend would already know to calculate 25 to the 1/2 times 25 to the 1/2. Well, in lesson 1 in unit 3, we reviewed our power properties. And if our bases are the same, we're allowed to add the exponents. So 25 to the 1/2 times 25 to the 1/2 would become 25 to the 1/2 plus 1/2 is 1. So you end up with 25. Okay? And then it says, explain why this means that 25 to the 1/2 has to be 5. Well, these are exactly the same, so I'm going to cover those up. And this times this ends up being 25. So what do each of these have to be? They're the same, 5 times 5. Okay? Since 25 to the 1/2 times 25 to the 1/2 equals 25, right? I'll use a different color here. And these are the same. These both have to equal 5. That's the only way you can get 5 times 5 to be 25. Okay. Number 3, which expression is equivalent to 16 to the 1/2? Again, 1/2 power is the same as saying the square root. So the square root of 16 is 4. And you could always use a calculator to double check these as well, using your exponent button, right? If you want to raise something to the 1/2, you would go 16 to the, and then depending on what calculator you're using, you know, if you're going to put 1/2 in, make sure you put it in parentheses. Desmos might be more intuitive. All right. Number 4, select all the expressions equivalent to 4 to the 10th. All right, so the first one, if we use our power properties, the bases match, we can add these. So this is 2 to the 7th. No. 2 to the 20th. Is that the same as 4 to the 10th? Well, I'm going to work backwards here. I'm going to start with 4 to the 10th. I know 4 can be written as 2 to the 2nd power. So instead of writing 4, I'm going to replace 4 with 2 squared. So I'm substituting that in for him, and then it was all being raised to the 10th power. Now, if I use my power properties, those two I multiply. So this is actually 2 to the 20th, which is the same. Another way you could do it is you could type it into your calculator, right? You could test, is 4 to the 10th the same as 2 to the 20th? It's going to be a really large number. Letter C, my bases match, so I'm allowed to add my exponents. This would be 4 to the 10th. That's the same. My bases match. I'm allowed to add my exponents. That becomes 4 to the 4th. No. Okay, letter E. When I'm dividing and my bases match, I subtract. That's the shortcut. 4 take away -6. 4 minus -6. That becomes 4 to the 10th. It is the same. Another way I think of it is when I see a negative exponent, I know they want the reciprocal. So if they're on the top and it's negative, I know they go down underneath. If they're on the bottom and they're negative, I know they come up top. So those 6 got brought up there with those 4 to make a total of 10. All right, from lesson 2, we were talking about square roots and cube roots. It says the table shows the edge length and volume of several different cubes. Complete the table using exact values. So I'm just going to remind you, if you have a cube, if you have the edge, right, to get the volume, you take the edge and you cube it. If you have the volume and you need to go backwards, right, the inverse of cubing is you have to take the cube root. So I'll put that over here. If you have the volume and you want the edge, you have to take the cube root of the volume to get the edge. Okay, so this one we have the edge. It's 3. 3 times 3 times 3 is 27. This time they're telling me the volume is 64. What would the edge need to be? What times what times what is going to give me 64? I'm going to take the cube root of 64, which happens to be 4. Okay, this time they're telling me the volume is 85. What times what times what equals 85? Now maybe we're not sure. Does 85 have a cube root? Let's take a look on a calculator. I'm going to use my TI-85. I'm going to go do the cube root of 85. And that is not an exact answer, so we're just going to leave it just like that. The edge length of a cube with a volume of 85 is the cube root of 85. Okay, now they're telling me the edge length is the cube root of 100. The cube root of 100 times the cube root of 100 times the cube root of 100, right? I'm going to write the work up here. That means I'm taking this, multiplying it by itself 3 times. That's to the 3rd power. That exponent is the inverse of that root. So I'm left with 100. And then it makes sense if I go backwards, right? If the volume's 100, then each edge is the cube root of 100. If the volume is 125, what times what times what is 125? Now, if you don't know that off the top of your head, it's not a bad idea to check. Whoops. Cube root of 125, 5. 5 times 5 times 5 is 125. Last one here. If the edge is the cube root of 147, what's the volume? That's just like this one. If I take the cube root of 147 times the cube root of 147 times the cube root of 147, that's like raising it to the 3rd power. Those are inverses of each other, and the volume is 147. Okay, and our last problem, number 6. A square has a side length of the square root of 82. What is the area? I mean, a square, all the dimensions are the same. So you're going to take that and multiply it by itself. Or, right, if you multiply it by itself, that means you're multiplying it, right? You're squaring it. And then just like this one up above with the cubing, if you have a square root and you square it, those are inverses of each other. The volume is 82. 82 centimeters squared, which is the same. I mean, if you want to look at it this way, you could also look at it this way. The square root of 82 times the square root of 82 is 82. All right, I hope that helped, and I'll see you soon.